For a number of years already, the Ophir Helios Plus has set the standard for high-power laser measurements in industrial settings. Ophir is now raising the bar even further with the new Helios Pro. Just like its predecessor, the Helios Pro measures industrial laser powers up to 12 kilowatts, covering multiple spectral regions. All it needs is a short pulse exposure, from as short as 300 milliseconds depending on the power. It measures the energy and the exposure time, and from this it calculates the power. The short exposure means there's no need for water cooling. The compact Helios Pro laser power meter is designed with factory automation in mind, with a sturdy, dust-resistant industrial body and a remotely actuated protective cover to keep it in clean working order even under harsh factory conditions. It uses robust connectors with 2 power ports and 2 data ports for easy integration into existing line or ring topologies. It's available in several variants to provide solutions for a wide range of interface options, including PROFINET, Ethernet over IP, and EtherCAT, as well as an additional RS232 interface. As we said, we're now raising the bar even further. The new Helios Pro has some new capabilities that really make it unique. An updated design makes the Helios Pro even more dust resistant. The Pro mode includes temporal pulse shape analysis and compensation of slow rise time for even more accurate power measurement based on the real-time measurement of the instantaneous laser power through the exposure period. Now, this is a significant capability, so let's understand what it actually gives us. Often, it's unnecessary for high-power lasers to stabilize particularly quickly. In applications such as cutting and welding, where the laser is on continuously for long periods, reaching 95% of stabilization may take hundreds of milliseconds, while full stabilization may even take a number of minutes. As far as the application is concerned, this is not an issue. But in recent years, with lasers being increasingly integrated into assembly lines where every second of downtime counts, there's a need to perform quick measurements. Also, there are cases where water cooling is not a practical option. In such cases, power measurement from short exposure is needed, and this becomes very challenging. Here's why. In pulsed power mode, we're taking a sample in time of the beam's power. We're assuming that the time sample accurately represents the average power, as it will be after full stabilization. If our laser has a slow rise time and an even slower stabilization time, an ongoing measurement would show that, but a short measurement will stop after the few seconds or less that it needed, and then we'll think all is well, whereas it might not be. We'll have measured the average power during the course of that short exposure, but that might not be an accurate indicator of what the actual CW power will be once the beam has reached full stabilization. And worse still, we might not be aware of it. In the example you see here, a pulse measurement of an 8-second, ideally rectangular pulse gives a correct reading of 5 kilowatts, whereas a pulse with an initial overshoot gives a reading of 5.23 kilowatts, incorrectly high by over 4.5%. Now we can appreciate the solution provided by the Helios Pro's Pro mode. The power from pulse measurement of the thermal sensor in the Helios Pro is combined with the temporal pulse shape analysis from the fast photodiode. This inbuilt temporal beam characterization capability calculates the instantaneous power level of the laser throughout the pulse based on the pulse shape. Because of this, the power measurement is independent of the laser rise time and of how much of the measurement time window it takes up. In addition to measuring average power, the new functionality also characterizes the 0 to 95% rise time and the stability of the laser at the end of the pulse. The bottom line result? As we said, compensation of slow rise time for even more accurate power measurement. New ordering options include the Helios Pro configured with a diffuser, allowing measurements closer to the focal plane with beam sizes as small as 2 millimeters.